Hi physics students, Addison here, and today we're going to go over a fun physics problem I came across with a student, so I thought I would share it here. So the situation is we have a 1,200 kilogram car that's zooming towards a spring at 35 meters per second. And we want to make sure that the people experiencing the de-acceleration that's going to happen when the car hits the spring, we want to make sure that that acceleration is less than or equal to 4 g's, okay? And so we're trying to solve for the k, the coefficient of the spring, such that the acceleration is limited to 4 g's, okay? So there's going to be quite a few variables at play to figure out what that k should be. Okay, so first of all, let's calculate what 4 g's is. So 1 g is the force of gravity is 9.8. So 4 g's is 4 times that, which is 39.2. And I'm going to write equal to because while we want the acceleration to be less than or equal to 4 g's, we're going to max out the acceleration. So really the acceleration is going to be equal to 4 g's, which is 39.2 meters per second squared. Okay. So now let's take a look. What do we know about this car in the beginning? Well, we know that it's traveling 35 meters per second and it's 1,200 kilograms. So the easiest thing to do is going to be to calculate the kinetic energy of our car, which of course is 1/2 mass times velocity squared. So let's go ahead and calculate that, and we get 735,000 as our kinetic energy. Okay, now we know that when the car reaches its most compressed state, so when the car compresses the spring all the way, okay, we know that when the car compresses the spring all the way, it will have no kinetic energy left, and it will only have potential energy. So the potential energy of a compressed spring is 1/2 kx squared, okay? And because of the conservation of energy, we know that this will be equal to the initial kinetic energy. Okay, so we're well on our way. We have this equation, 1/2 kx squared equals 735,000. So now the question becomes, okay, how do we figure out k? Well, clearly to figure out k, we need to figure out x. Now, how are we going to figure out x? Well, we have to connect this to the unused piece of information, the acceleration. So how does x connect to the acceleration? Well, the force of the spring that the spring inputs is kx. Okay? We also know that the force is equal to the mass times the acceleration, which is equal to 1,200 times 39.2, okay? Which is equal to 47040, okay? So we know that the kx is equal to 47040. Now, here's where we can do something kind of clever, because now we have a system of equations. Let's put those in red. We have kx, okay, is equal to 47040, and we have 1/2 kx squared is equal to 735,000. So we know from algebra that's 2 equations and 2 variables, so we can solve this. Now, what's the most clever way of solving this? Well, 1/2 kx squared is the same thing as kx times 1/2 x. So I can pull a kx out of that equation. And the usefulness of that is that I know what kx is equal to. So now I can substitute for kx 470/40 times 1/2 x equals 735,000. Okay, so now I just solved that for x. So we just solved that for x, and we get 31.25. And then we know that kx is equal to 470/40, so we simply set that equal to k times x, which is 31.25, and we divide by 31.25, and we get 1505, and of course this will be in newtons per meter since it is the spring coefficient. Okay, so just a quick review. We figured out the facts. We have the acceleration, the mass, and the speed. And we started to try to put those together to solve for k. So we figured out the initial kinetic energy. We figured out the equation for the potential energy, which has our k in it. And then to figure out the x, we brought the acceleration in to determine the force. And the force, of course, is kx for a spring. So we were able to connect the facts that we know to solve for the unknown fact. And that involves quite a bit of math. It also involves some creativity, which I particularly enjoy about physics. So here's a fun problem. I hope you enjoyed it. If you're in need of tutoring services, please reach out. Addison Academy, we offer math, physics, English, and test prep tutoring. So thanks for joining us. Appreciate you.